Hi everyone, my name is Gurmeet. I'm a staff engineer at Uber, and in this talk I'll be talking about the Presto Query and workload governance work that we have done at Uber. So this is a work this has been done, has contributions from a lot of members from the Uber Presto team and also from my co-presenters Hitarth and Yasaman. So in this talk, I'll be talking a little bit about the scale of Presto at Uber with some numbers, and then talk a little bit about the challenges and issues that come from running Presto at such a scale, followed by an introduction to the query processing flow at Uber. Then Hitarth will be talking about query gating and rules, and Yasaman will be talking about the quota management and the future work. So Presto has a pretty big presence at Uber. We have around 20 clusters and about 12,000 nodes comprising of around 100,000 vCores. These clusters are spread around 3 regions, and we have also around 7,000. The Presto at Uber serves around 7,000 weekly active users. We run about 500,000 queries a day and read about 90 petabytes of data per day. So the Presto use cases at Uber can be broadly divided into 2 buckets. One is the interactive use cases and the others is the batch use cases. So for the interactive use cases, we have a SQL editor UI frontend, which the users use to write the SQL queries, and these SQL queries then run on our interactive clusters. These clusters are dedicated just for running interactive queries in order to guarantee some short SLA for those queries. The other bucket is the batch use cases, and there are lots of them at Uber. For example, reporting for dashboards. We have dashboards like Tableau, Google Data Studio, for which the queries run on Presto. Then we have the ETL workload, and we also run a lot of the data quality checks at Uber run on Presto. Also, the experimentation runs on the batch, as well as ad hoc analytics from the Jupyter notebooks, as well as some custom services which serves the riders and the drivers. So basically, there are a few challenges and issues that we encounter because of running Presto at such a big scale. So the first is kind of the increasing resource footprint. So as you can see, the number of cores serving Presto has increased steadily from about 60K to more than 100K in about a year. So with the increasing footprint, the cost of running Presto also increases. And the second issue is that Uber at Presto is a shared resource, and we don't segment the resources into different use cases in order to avoid fragmentation. But because of that shared nature, the issues that we also encounter is that now users can put arbitrary load on the collective system. And while we have some limits in the number of queries that a user can run at most at one point of time, still, like the queries, the Uber Presto queries can have very different resource requirements. So we see that the top few percent of the users end up using a lot of the Presto resources, and Yasaman will be talking a lot more about this issue later in the talk. The third issue also comes from the shared nature of these resources, is that because the resources are shared and any user can submit any query, now we still have to guarantee an availability of the Presto resources for the rest of the users. So we have to impose limits on how long a query can run before it is killed. So we do see some queries that end up getting killed. While the number of such queries is not a whole lot, about 2 to 5%, but still they end up wasting about 20 to 30% of the cluster CPU resources. So that's a lot of wastage. The other challenges is there's a very limited life cycle management of the scheduled workloads. So while some platforms provide some management like the frequency control, the expiration of the schedules, as well as the number of retries and all, most of the ad hoc workload that comes to the Presto batch clusters don't have any management. And also there is no incentive for the users to manage or optimize their queries because there is no chargeback to them in order to run their queries and because the shared clusters are collectively used. And also the system has to provide, the users have come to expect some kind of SLA from the clusters, even though we don't have a hard bound on the number of workload that we accept. So earlier in the day, Bhuma talked about some real-time analytics workloads on Presto, right? So while at Uber, we don't use Presto for real-time use cases, but users have come to build some use cases which kind of implicitly expect that SLA. And they expect the system to provide that SLA. So the other challenges is that while you see that Prestissimo and other optimization efforts can bring a lot of efficiency into the system, but still we see that most of the optimization wins can be very easily nullified by a new unoptimized workload that comes into the system. So this governance has still to be done on top of any underlying engine optimizations that we end up doing. So this is the system architecture of the system as it existed before we started working on the governance. So when a query is submitted by a user at Uber, it is accepted by a system called Query Runner. First, the query is validated to make sure there is no syntax error. So it is sent to a dedicated Presto cluster we just used to run an explain plan on the query to make sure that the query is valid. After that, the query is queued up in the underlying system. And then based on the concurrency limit, what is allowed to the user, and based on the cluster's availability, at some point of time, the query is released to a system called Prism, which is a routing layer at Presto for routing Presto queries to one of the clusters. And then the query eventually runs, and then it publishes the query stats to Kafka using the Presto event listener framework. And that Kafka data is eventually ingested into Hive, which lets us do the analytics for dashboarding and other purposes. Yeah, we used to have separate cluster for explain. For our governance, we realized that we have to develop some fundamental technologies in order to implement the projects. So for example, first we have to develop an identification system for a query. So when a query comes to the system, we have to be able to tell that this query is the same query that came previously. And this identification system has to be smart enough so that it is can tell if it is a simple change in the query, such as an additional comment or some white spaces added by the user, or one of the upstream services which sends the queries to us. And also it has to be smart enough to figure out if the same query is coming from a pipeline with a moving window. And also we need to, along with the fingerprint, we need to get real-time historical insight. So as the query comes, in a matter of milliseconds, we have to figure out when did this query run before, what was the profile of the previous runs of this query, and then make some routing and other decisions. The other technologies like getting bad queries, Hitarth will be talking about it, and user level limits, Yasaman will go deeper into it. Also fundamentally, we found that we have to actually build a lot of observability about the analytics itself. So users need to be able to, given a query, be able to figure out what is the resource usage of that query, and then what was the profile of this query in the previous executions, when did it run before, and what was the result of that execution. And also we found that while Presto is the underlying engine, it helps a lot to build governance into the upstream platforms. So for example, by sharing our insights with the upstream platforms, we have helped them build governance at their end itself. And that helps because they are actually closer to the user, and they can do much better user outreach than we can do on our end. So this is the new architecture that we use at Uber. So now when a query comes to, is submitted, it is now, instead of the explain clusters, it is sent to a service called Preon, which is a service that we have developed in-house, which is basically, you can think of as a Presto coordinator without any of the execution capabilities. So this, we have implemented a number of endpoints in this service, and we run it in a microservice form factor, which helps us scale the use cases. So now, as soon as there's an increased number of requests to the service, the underlying infrastructure can spin up new instances of this service. And we have used it in a number of use cases. For example, in PI detection, we need to be able to figure out which are the columns and the tables that the user is trying to read in this query. And based on the user, we can actually fail the query or give a earlier warning to the user instead of actually encountering it while running the query. We also have used it in a query result caching service in order to figure out if any of the underlying data sets being queried has changed. We use it also in the GPT-like frameworks, where the framework uses it to validate whether a query that it's trying to formulate based on the conversation with the user is actually valid or not. And I will be talking about for the query gating, and also we use it for the routing. Based on the tables accessed in the query, we can route it to the appropriate clusters or to Presto on Spark if we find that this query is actually not suited for our existing Presto clusters. And also we have a later talk in the day today where we'll be talking about another use case, which is Presto Query Express. So now when the query comes to Preon generates all the insights as well as the fingerprints, and those insights flow down with the query to the next system where the query is queued up. And after the user concurrency limits are met, the query is released to the Prism, but along with all the attributes that have collected so far. Those attributes are then passed down to Presto through a header called client info, which is used to send client-related informations. And those attributes, along with the runtime stats of that execution, just like before, are published to Kafka. But now we also ingest the Kafka topic into a Pinot table, which actually helps us in real time generates insights for the queries as and when required by the projects that we'll be talking about. So now Hitarth will be talking about Presto query gating.
Thank you, Gurmeet. So basic objective of Presto query gating was to tackle the three problems that we earlier spoke about, which is the increasing resource footprint, significant resource which were used by failing queries, and there was no incentive for users to actually optimize or manage their own queries. So based on the analysis that we did, we found that a lot of the queries were failing with insufficient resources, which, although in terms of percentage, they were not significant. You can see around 3 to 4% of queries were failing with insufficient resource. But in terms of the amount of CPU they consumed before they failed, that was significantly high. So we saw that around 25 to 30% of CPU was getting wasted for queries which were eventually going to fail with insufficient resources error. So that prompted us to think about gating such queries before even they come on Presto to run. So one of the main critical component of query gating is query fingerprints. How do you identify whether this query has run before and has failed in the past? So in order to do that, we developed in-house query fingerprints. There are two types of fingerprints that we have. One is exact fingerprint and another is abstract fingerprint. In exact fingerprint, as you can see from the example here, we directly take, we pass the query and take its hash. Query which has a filter, for example, column equal to 1 or column equal to b, they will both have two different fingerprints. Whereas for abstract fingerprint, we parse the query and remove constant values from it. So by doing that, the two same queries will now have same fingerprint. So using this fingerprints, we were able to club different queries and we were able to see their historical patterns. So the core gating engine does three things. It will either not block the query or send a warning if the query is at a threshold of being failed, or either fail the query or either block the query. We developed different rules. So a query can be blocked for multiple reasons and they all can be categorized into different rules. A rule can have properties, as you can see here, like name, face, consumers, a query, a message, and the status of the rule. I'll talk more in details. So we have two different types of rule. This depends on how we determine whether the query has failed or not. So offline rule is where we look at historical data through our event logs, which can date back to like 2 weeks or even a month old data. Whereas for online data, we rely on Pinot, where our event logs flows into Pinot, and we tend to look at around 24-hour range of data. So for offline rule, we have a background job which runs and collects such bad fingerprints and provides this information to Prion service, which is doing generating the fingerprints and checking if this fingerprint is actually in the list of bad fingerprints or not. And based on that, it can either block or warn. And similarly for online, we go to Pinot to get this information in real time and take appropriate actions. So in order to get the accuracy of rules, we have three different phases a rule can be in. In warning phase, a rule will either, it will not block, but it will just send an OK signal or a warn signal. In a shadow phase, it will pseudo block, which means it will collect the logs that had this been blocked, what its end state would have been. So in that way, we can check the accuracy of a rule. And once we are satisfied with the accuracy, we go to the last phase, which is the blocking phase, where the queries will start getting blocked actually. So here is the flow. The query goes to a gating manager, which first generates a fingerprint, and then it keeps applying the rules. If any of the rules is going to block the query, then that response is given back to the user. Otherwise, it keeps on applying all the defined rules for that query. So here is an example of such rules. The first example is the high failure rate. If I have to describe that, we will, any abstract fingerprint which has a failure ratio greater than 50% and a failure count greater than 20 in last 2 weeks, they will start getting warned. And once we have warned such queries for more than 5 times, and an exact fingerprint of that has seen a failure in last 24 hours for more than 3 times, that's when we take an action and start blocking it. Similarly, for an hourly inline rule, if a query has failure count greater than 1 in last 1 hour, then we'll warn it. And if it has failed more than 3 times in last 1 hour, the same error, then we'll block it, right? So those are the 2 different types of error. And based on, after we turned on this feature, we have seen CPU savings of roughly close to 5 to 6%. So yeah, that's all from me. Over to Yasaman.
Do you know anything from these blocking queries? Like, do you take any measures to avoid them in the future?
Yeah, so we do warn the user and we provide observability to user as to which queries are getting failed so that they can take action. And we also have a page, an optimization guide which they can follow in order to optimize the queries further.
So is there any AI running behind it, or is it like?
So far, there's no AI.
Does the fingerprinting take time?
No, it's pretty fast. It's using the same parsing thing which.
The filters and all, like, do they have like time-based fields as well? Or?
Yes, they do have time-based.
Most of the time we use abstract fingerprinting.
Let's repeat the question so they can capture the question as well.
Sure, I can repeat the question. So you were saying most of the time.
We are using abstract fingerprinting.
Oh yeah, so for in order to categorize the query, we use abstract fingerprint, but then we are also providing user ability to optimize the query as well. So in order to block the query, we are looking at exact fingerprint. So we are using combination of both abstract and exact fingerprints. Thank you. Over to you.
So in the next section of the talk, we want to share our experience about launching another gating rule for the daily CPU quota usage. We have already discussed in details what are the challenges that we were facing, and then the idea of having a quota for the CPU usage is going to address some of these challenges that we are facing. We are noticing that our resource footprint is increasing. We are seeing that arbitrary usage are putting an extra load on our cluster, Presto clusters. We also mentioned that we don't really have any lifecycle management for our workloads. And then once a single user tries to optimize their query, since it's actually shared resources, they don't really see much benefit. Also, for us as an admin, it's really difficult to define SLA. So we decided to explore the idea of having a daily quota for the CPU usage. And then this was based on some of the observation that we were having based on the Presto clusters. So if you want to define a quota, you can have different metrics that you can define your quota based on. It can be based on the number of the queries that our users are submitting. It can be based on the resource usage. So what we've noticed is that at the end of the day, it doesn't really matter how many queries a single user is submitting. What really matters is that how much resources they are using. The other observation was around, and then the other thing was that there are already some integrated solution for resource management. For example, Presto provides resource group. However, the solution that we use, it needs to match the criteria that we had for Uber Presto ecosystem. Because when the users actually submit their queries, this is when they decide that, okay, how should we route the queries, and we need to make all those decisions at the very high level. The other observation that we had was that specifically for daily CPU usage, the P95 of the CPU vCore usage per day, it's within very certain limits over like basically over on daily basis. So if we pick this specific limit, we can observe that most of the usage is around that. The other very interesting observation was that 80% of resource utilization is from 10% of the users. So if we can find a mechanism to engage those users to somehow optimize their queries or manage them more efficiently, we can. There's a huge potential for us to basically save resources. Based on this idea, we based on also the gating mechanism that Hitarth just talked about, we defined just a new rule. So what will happen is that this rule has become part of our gating mechanism. So once the user submit a query during the validation, we also exercise this extra rule. So to make a decision about the gating for daily CPU quota, we need two pieces of information. First is that what is this specific user's daily limit, which we have a DB for it, and then we are calculating this limit based on their usage pattern in the last 30 days. And also we need information about, okay, what is their current usage in the last 24-hour window. And that we are capturing with this recent real-time insight mechanism that we have launched. So using these pieces of information, the gating can decide that, okay, if I have to, if it's okay, if I have to warn or I have to block this query. For us to actually launch this, the big part of this rule is that user needs to actually engage and optimize their query. So what we really need to provide them is the more observability at the query level. So they kind of need to exactly know that, okay, how many queries I'm running? What is the CPU usage for each of them? What are the failure rate? How much like a wasted CPU do I have? So all these information are kind of assisting the users to optimize their queries or basically following some solutions. For us as an admin, we also need to have a different functionality. For example, if the user is blocked, we kind of instantly need to unblock them. For example, we should be able to instantly adjust their limits. So whatever observability features or whatever mechanism we provide, at the end of the day, there will be some users with some blocked queries. So what are the options? So the users, what they can do is that they can actually optimize their queries. They can also revisit their Presto workload. For example, they can adjust the frequency or scheduling. Let's say your data source is getting data updated every day on daily basis. Is there any reason for you to run your query every hour? Or if you have a weekly pipeline, is there any reason that you are running all your pipelines in certain day of the week? Is there any way for you to kind of distribute it? And also, we have launched the functionality to run your query on the Presto on Spark, and it's going to be as easy as just like setting a flag. So user has an option to run their queries on Presto on Spark. Once they do that, they kind of get exempted from the quota usage. In the two diagram that you see on the bottom left is that in the left-hand side is this is an example of the user scenario that the user CPU usage has been decreasing while their number of the queries that they're submitting actually increasing. So we are saying that once the user actually getting engaged, we can see a lot of benefit on the resource optimization. Okay, so well, about the learning and insight that we had from this experience, we see that yes, we have provided these limits, but there are these cases that the users for the short period of the time, let's say there's a data scientist, they want to collect some data for generating, let's say, some features, they want to collect some data, and for the short period of the time, they want to get some exemption. So it's really helpful if we have an automated mechanism to allow the users to ask for that. The other helpful thing was that we need to kind of interactively engage users. So more alerting or more notification we have for the users that, okay, your quota is reaching the limit. Or for example, during the last week, there was these 5 queries that we have blocked. You may want to kind of revisit them. This will be super helpful for the users. The other observation that we kind of also foreseeing happening is that not all the usage pattern fall within the daily usage. So for example, there are users that will have this pipeline running only on Tuesday or running on the middle of the month only. So we kind of need to consider those type of use cases. And now we see that with user level quota limit, users are directly kind of seeing the benefit of optimizing their queries. We are also seeing that our clusters are guarded against the sudden spike in the usage. Just looking into the result that we get from this experiment, we are saying that our CPU usage got reduction was around 20% since we've launched, and the latency of the queries was around 40%. Looking into the future work, what we are planning to do is that we want to even emphasize further on the gating mechanisms that we have to minimize the wasted cluster resources. Also, now that we have on Presto and Spark, we have already started an effort to make rerouting to the Presto and Spark dynamically. So we are basically allowing to, under the hood, without getting engaged with users, we redirect the queries over there. We have explored this idea on the batch workload, but the batch workloads in nature, they have different categories. So for example, you have the ad hoc, and then you have these workload that they are doing backfilling, or they are certainly scheduled. So there's a room for us to explore that if we can adjust the scheduling of different category, kind of having a customized solution for scheduling along with the quota management. The other thing that we find it is going to be very important is that so many of the effort is like we are kind of optimizing Presto engine, but in this query governance what helps us is that we are kind of optimizing getting help from the users. So it's really important that users that are sitting in the commander seat, they have a detailed observability about their usage, even having some dynamic suggestion that, okay, you can adjust this query, or you can adjust the schedule of this. So giving more observability, utility, or engaging the users effectively will kind of pay down the line. So now I think we can open the room for the questions, if you have any.
Sorry, what was the question?
The very first slide somewhere.
Yeah.
You had data coming from HDFS.
Right.
I thought you have your table format query, right? Where is that HDFS?
Yeah, even the hoodie data sits in HDFS. Yeah.
Are there any plans to make it open source, this quota management and
Right. So at least, so we are starting with trying to create a PR for the Prion service. When after that, it's I think we'll have to engage with the community about what's the right way, what is the right framework to add governance in the Presto project. So I think so that's one of the motivations for this talk, is to kind of highlight this issue and find the right place to add the governance in the Presto project itself.
From what I know, Presto does have like resource group support on kind of limiting user or group creating resource groups. I did see somewhere in the slide that it doesn't fit your case. Could you explain a bit more?
Yeah, so the problem is that, let's say it has you can limit a user to a number of running queries on one cluster, right? So it's a cluster level solution, but we have multiple clusters that are running. So if a query goes to a cluster and gets queued there, it cannot run on some other cluster. So we need to make this, have the same functionality at a Uber level. Sorry? Yeah, so the result caching, basically what it does is that once a query comes to Prion, the caller tells us, hey, like this query, it was run 2 hours ago, right? And then Prion, based on the data sets that the query is trying to read, sees whether anything has changed in the last 2 hours. So basically, so it's a combination of upstream caller, which knows when this query was last run. And from the Presto side, we provide the intelligence as to whether something has changed underlying in the last 2 hours. If nothing has changed, then the caller can just return the previous result to the caller, to the user. No, it is result, like the results from that Presto returns is stored in some, like in our case, query runner is the upstream service, which stores in their own kind of storage.
Maybe can you share some insight, like how many queries benefit from?
About 6 to 10% generally we see, which are actively hits. So they are kind of we are actually returning cached results for those queries.
One question is, in the beginning you have like two clusters, interactive cluster and batch workload cluster, and notebook was somehow in batch workload cluster. Like, but to me, like notebook is interactive. Is it like just running notebook like from whatever, like from the first cell to the last cell, one by one? Is it what you meant by notebook in batch cluster?
So actually, I think when Yasaman was doing her work on the quota, we saw that a lot of the workload is also coming from the Jupyter notebooks, where the users have written some Python code and they are using the client to actually call Presto. So that's what I meant by notebook analytics. I'm not sure.
So just to add one more thing. So when we are doing the routing, it doesn't necessarily fall into the category of the interactive and batch. Right now, our queries are coming from different sources, and that specific notebook source goes to our batch cluster. I understand that maybe like conventionally doesn't fit it, but just this is how it got routed. Yeah.
How they run this notebook, basically. Maybe it's like scheduled, like some process scheduling this notebook.
Yeah.
Okay,
Thank you.